We're going to talk about the PQ problem today. The PQ problem is used in the make-buy decision or else in the product mix decision. In the product mix decision, what you're trying to do is develop a product mix which is the most financially profitable for the organization. There may be some other criteria that are evaluated also that lead to a less than maximum profits product mix, but we're going to calculate using the PQ the absolute best financial results for the company. So we have a couple of pieces of information that we need first. We need to know that the work week is 40 hours and that no overtime is needed. We also need to know that the operating expenses for the week are $6,000, and we need to know that there is one of each type work center. Alright, so there's only one drilling unit, one pasting unit, one packing area, those kinds of ideas. We have three products, alpha, beta, and omega, and we need to know some information about those to do this calculation. So the first piece of information is we need to know what our selling price per unit is. And for alpha, we're going to say that that is $85. For beta, we're going to say that that is $100 per unit, and then omega will be able to sell for $60 per unit. We also need to know that the quantity per week that we can sell, not make, but sell, is for alpha 100. For beta, we can sell 50 and no more. And for omega, if we make 100, we can sell 100, but we cannot sell any more than that. Alright. Now we need to know what the flow through the system is going to look like. So the thing that we're going to look at here is the actual layout of the flow. And in this case, we're going to have work center D is going to be the last work center that will work on making a product alpha. We also will pick up that we might use a purchased part, and we need to know the cost of that purchased part. So each one of the purchased parts that goes into work center D to make an alpha will cost us $5. I'll come back and format all these numbers here in a little bit after we're done. And a product alpha produced at work center D takes 10 minutes per unit. That product alpha, work center D, gets its work from work center C, and work center C takes 10 minutes per unit. That input comes from work center A, and that work center A to make a product alpha takes 15 minutes per unit. But units of raw material 1 cost us $20 per unit. Now these are not the only things that are needed to make a product alpha. So we also need some work done at work center C. This is different work though, and it only takes 5 minutes per unit. In this case, this might be drilling a 1/2 inch hole that takes 5 minutes per unit, and this might be drilling a 1 inch hole that takes 10 minutes per unit. So it's the same type of operation, but the amount of time taken to do the two different work center operations differs. It is not the same. We also have to get some work center B work in there, and that will take 13 minutes per unit. Now work center B doesn't just work on air, it's got to get some raw material too, and each one of those raw material units costs $5. I'm going to take a break just for a second. Alright, while I was away, I formatted the spreadsheet for us. So as you can see, got the dollar signs in there. These are units per week. I added a 10 in here because I had not added that in before, but it takes 10 minutes at work center D to make a unit of alpha for sale. And takes the purchase part. So what I need to do is I need to put in some small indicators of direction. I'm going to use some small arrows just to indicate what's going on here. And make a couple of these. Okay. Now I'm going to hold off again for a minute just to be able to finish putting the rest of these arrows in. You don't need to be watching while I'm doing that. So hold on just a moment and I'll be right back. Alright, so I've added the arrows to indicate the direction of flow. So you'll notice that both of these columns of work need to be done, and then finally it's assembled, or whatever D is, to make each product alpha. Now to make a product beta, we need some work done at work center D again, and that work will take 5 minutes per unit. We need some work done at work center C over here and work center B. And we also need some work done at work center B, and that's going to take 15 minutes per unit. And we need some work done at work center A, and that's going to take 4 minutes per unit. We don't have the raw material in here yet, so we're going to add raw material 3, and that costs us $13 per unit. Now I'm going to draw the arrows in here again in just a moment. I'll come back to that, but I want to go ahead and put the work centers in for product omega. So that's going to be work center A, and that will take 3 minutes per unit. Work center C, and that will take 5 minutes per unit. And work center D, and that will take 10 minutes per unit. And again, we have to have some raw material to work on, so that's raw material number 4, and that will cost us $12 per unit. Alright, I'm going to go ahead and connect all the arrows in here again, so I'll be right back. Okay, as you can see here, I've added in the rest of the logical process flow. The arrows are in to indicate the actual flow of products through the process. So let me explain. We'll start with alpha, product alpha, and we're going to start with raw material 1 and what happens to it to make a product alpha. So raw material comes in at $20 per unit and goes to work center A, where it takes 15 minutes of processing. Once that 15 minutes is done, it moves to work center C, and from work center C, where it takes 10 minutes, it moves to work center D. Now at D, it takes 10 minutes of work, but it also has to be combined with $5 of purchase part. Not only that, we have to get some raw material 2 in there at $5 a unit. And that raw material 2 goes to work center B, which takes 13 minutes per unit to process, which then transfers to work center C at 5 minutes per unit to process, and finally ends up at work center D at 10 minutes per unit to process, resulting in 1 alpha. Okay? Down here we start with raw material 3, and we have it sent to work center A, taking 4 minutes per unit, which then transfers to work center B, taking 15 minutes per unit, and that ends up at work center D, taking 5 minutes per unit. But that alone is not adequate to make up beta, so we have to come back over here and catch some raw material 2 at $5 per unit, which then goes into work center B, taking 13 minutes per unit to produce, moving to work center C, taking 5 minutes per unit to produce, and then it moves to work center D, where it's combined with the stuff from the first column here. Alright, to make an omega, I'm going to start with this one, raw material 3 at $13 per unit, going into work center where it takes 4 minutes per unit to process. That will then transfer straight to another operation at work center, which will take 3 minutes, but that again is not adequate to complete the work to make an omega, so we have to add some raw material 4 at $12 per unit, which goes into work center D first, and that takes 10 minutes per unit. Once it's done at D, it goes to work center C, taking 5 minutes per unit, and after that it goes to work center A, taking 3 minutes per unit, where it's combined with this work down here, resulting in 1 omega that can be sold for $60. Alright, now the next process we'll talk about in just a moment is going to be to calculate the need for work at each work center. So this that we have now, the logical process flow, simply diagrams graphically the flow of production in the facility.